Hey guys, I am back with some colony building. 1 second. I have to start my playlist. My I'm super gonna work now playlist. Okay. So I was at the point where I could have some voxel worlds and I can save and load stuff. Loading takes a while because it's not optimized at all. But that's fine for now. And now I want to turn this into a graph. So I can run my pathfinding. And for that, I have to remember how all of that worked. It's been a while since I've done that. Map spawn system. I think that was yeah, we have the spawn date, entity, map size, yeah. Spawn count. Okay, so this generated a 2D graph that we were then able to A star upon. This needs spawn data. And then create nodes. Each node is an entity in the graph. And this node float 3 holds the position of the node. Although I could just as well use the transform. So for this new version, I need the position and the rotation. So I think it makes sense to use the transform because this has both built in. Is walkable I don't need for now. Tile data. tile ID. Yeah, and I need a way to represent the type of block. So this creates all the tiles, and then this sets up all the transitions. No transition buffer. Okay. Let's make a new folder. Voxel. And I'm gonna call this Voxel map spawn system. It doesn't really have to be a system. Hmm. Hmm. Voxel map spawn system. Yeah, I think I'm gonna make it a system. Hey Nono. Nono El Chapo? How long have you been coding for? You look pro. Thank you. I have been coding for... Wait. I'm turning 36 in a bit. So... Yeah, that's... I think I've started... Like really started at 19. So that... Yeah, you do the math. I'm just gonna copy all of this for now. I've been professionally in the industry for since I was 23. So I'm coming up on 13 years. Okay, so we have the int3. We need a new type of spawn data, which uses the voxel stuff. Voxel map spawn data. Just copy this. We don't need this. We do need the tile entity. But I'm gonna call this voxel entity. Spawn count we don't need. But then we need the reference to the world data. Yeah, so this needs voxel map spawn data. Oh yeah, wait, this needs to be a system. Systems are now partial struct. Nice system. Walkable, we don't need node float 3. We don't need tile ID. New tile data. Let's see. We need the tile data to say which type of voxel we are looking at. Yeah. Okay, so we'll also create a voxel data class. This also has to be serializable. Voxel data. Don't need this. We call this a voxel type. I think I'm allowed to use enums here. So I would... Oh, wait, first we have to get rid of all the errors. Some question. Usually, what steps do you take when you don't know how to do something? Well, nowadays, if I'm completely clueless, I would just ask ChatGPT. So if I'm sitting in front of a problem and I don't even know how to approach it, I would just ask ChatGPT, hey, I'm facing this problem. Do you have any ideas of how to solve that? And then usually it would come up with a list of algorithms that deal with that specific thing. And yeah, then I would just look up the algorithm and try to understand if it does the thing that I needed to do. And then go from there. Usually when you have like something that's in the vicinity of what you need, then finding the thing that you need isn't that difficult. Back in the day, it used to be a little more difficult. I'm actually so glad to hear that. No, I think you shouldn't use ChatGPT as like a crutch for writing code. It can do that sometimes, but oftentimes the code will be buggy. But I think for suggesting like algorithms or giving ideas of what direction you should take, it's a pretty valuable source. Just because I'm still early in the learning process, I try to avoid it so I don't become dependent on it, but sometimes it's a lifesaver. Yeah. I don't think you should avoid it. I think you should learn how to use it, but especially if you're new, you shouldn't just copy the code unquestioned. You should always try to understand what it does. I mean, it was very similar for me back in the day. I would just go onto Google and look at Stack Overflow or Unity forms or what have you, and copy code that I found, and hope that it does what I needed to do. But you actually have to make the conscious effort to understand it. Are you a full-time game dev? Yes. Currently freelancing. So at the moment I have a bit of free time on my personal projects. Voxel type. But that's gonna change pretty quickly. Oh, voxel types. Oh, yeah, this is internal. This has to be public. Do you have a Steam page? Not really. There are some games on Steam that I have worked on, but they're not under my name. So earliest title I worked on way back in the day was Quantum Rush, which was a racing game, which is still on Steam. Okay, so I can do this. So we have the voxel type. So I have my world data. This is my data that describes my voxel world. And I need to reference this. I cannot reference this in a component. So how do I actually do that? Yeah, I think this shouldn't be a system then. Let's not make this a system. I think this just makes things more complicated than they need to be. We don't need this. We don't need that. Voxel map spawner. Or Alright, I'm going to sleep. It's 2 AM here in Costa Rica. Oh, but I wish you best of luck. Thank you. Have a good rest. Oh, thanks for the sub. Voxel map spawn. Okay, so we don't need the random either. Create graph. Let's say I just have a method where I put in this voxel world data. Make this public also. No, yeah. Or do I want to use interfaces? Nah. Voxel data, this also has to be public. Rotation has to be public. Voxel world data. Okay. Still thinking about a better name here. Maybe Voxel Graph Creator? Voxel Graph Creator. Okay, so we do need this. We do need the voxel entity. Dictionary. So this is just the position. So I'm gonna make this a vector reint. Okay, and then we can say date for each var chunk in data. For each voxel in chunk. Oh, yeah. We should call this voxel. Voxel data. I can't think of any good names. Let's just call this component then. So this is unique. So for each voxel in a chunk, we're then gonna say I just realized that I don't have a way to find neighbors in the neighboring chunk. So neighbors of one voxel in the neighboring chunk. So I need my default world and I need an entity manager. Let's see, what is my tile entity? Is there anything important on there? Data tile. Okay, this is literally just an empty. Oh, but there are some components that it will add for you. But I don't think I need anything really. I should just need the local transform. Okay, let's see. So I'm gonna voxel entity is entity manager instance here. Create entity. Entity manager, add component data, local transform. Voxel entity new position is voxel position times chunk position. I'm of course assuming that the entire world is loaded always, just to make stuff simpler right now. Load. Can I cast this? Vector 3, flow 3. Okay. We need, right. Need rotation, which, wait. No, I don't really need the rotation. I mean, not like this. Do I? Because I only have 4 rotations. Okay, no, I don't want the local transform then. I'm gonna use this component here and call this int3. Int3 position and wait. Can I use this? I don't think I can. Let's just use a byte, I think. And we're gonna say voxel data component position rotation is voxel rotation value. Voxel type is voxel type. Int 3. Can't be done. It's too complicated. Okay, then we're gonna make a class value conversion helper static public static int 3. This vector 3 int value return new value x value y value z. Okay. So that should be almost everything we need. We also have to define which voxels go up and down. Okay, I'm gonna think about that in a bit. So that would be this. Wait, we have to add this to the tiles. Tiles new. This doesn't even have to be static. Just put this in here. And we say tiles var plus is a voxel entity. Nodes. Wait, how's this different? Tiled. Nodes. Why do I have to? Oh, this is a native hash map. Ah. I think I needed this to look up all the entities. Native hash map. Shouldn't that be the same? Tiles, target value. Yeah, should be the same. I want to say I don't need this. For each entity in tiles, get a value array. Allocate assistant. Using this tile entities. Temp. I think temp is the correct one here. Okay, dynamic no transition buffer. Can you please open this? Okay. So this is a list of neighboring nodes. Position in 3. Oh wait, it can't. No, I think it is int 3. Yeah. No, it's correct. So the position is full integers, even though the blocks have half height, but that's just a representation thing. Position. Wait, why don't I just tiles? Key value pair. Yeah, this is much easier. Position. is key and entity is value. Okay. So we add the transition buffer. This is my neighbor. Tiles, try get a value. Position X -1 Y and position Z. Like this. So this would add all the neighboring blocks. And for amps, we need to find the direction in which the ramp is facing and then add the neighbor one higher. Okay, tiles, tiles, tiles. New. Can I maybe just put this into a method? Not really. Position Z. And same thing here. Comment this out for now. Okay, so this would be the default for a flat map. And I have defined that the up direction for all ramp type voxels is always in -z direction. So voxel types. I need some function that tells me whether this is a ramp So hmm. Hmm. I'm gonna just make a static class. Voxel type helper. Public static bool is ramp voxel type return type is slope or type is there. And then I'm gonna use that here to say if voxel type helper is ramp I need this info. Let's make this a tuple. Voxel data component. Voxel data comp. Is this? Comp. Value item 1 and the data component is item 2. And we say comp voxel type. If this is a ramp, and then we do, if this is not a ramp, also the question is, do we always mark these as neighbors? Because now we could be in a situation where there's something on top of your neighbor. So you are here, this is your neighbor, but there's something on top. So now you can't go there. Oh yeah, also if your neighbor is none, for instance. Yeah, the graph should already be... I mean, not... In the 2D version, we also had non-walkable tiles. But those were still part of the graph. Yeah, I guess we could have entities. Well, for one, you could have entities that can walk on water, for instance, or that can fly. So we really need all the neighbors all the time. Yeah, okay. At least I think that makes sense for now. But then if you're flying NPCs, they could also just go up, maybe? So the question is, do I also add the up and down direction as neighbors? No, let's keep it simple, kind of simple for now. So why is this? Oh, this has to be this. But then this can't really be static. Okay, wait. I have to rethink this. So we basically have two options. Either we connect every voxel to every neighbor all the time, and then on pathfinding we find the neighbors. Oh, wait. I could have different graphs for different types of units if I need it. And then I would just call this maybe walkable transition buffer. And then whenever a voxel is changed, I have to recalculate that part of the graph. The thing is, if I keep all the voxels in my graph all the time, that sounds pretty inefficient. Especially for big worlds. And in my A star, let's check out my A star implementation again. So this is the 2D version. Blah, blah, blah. We do all of this. Here, neighbors. We get the G-score. Try to get a value. Wait, there was another step in between. Where I merged all the nodes. And that's why they didn't walk on water. So I created all the nodes and connected all the neighbors. Like so. But then in the second step, we had this. What was it? Node merger. Which takes all the nodes in my graph. It's the tile aspect. Merge nodes. And this creates a rect. Basically, it merges all the nodes that form one rect into one entity. So the pathfinding is faster. Can extend. Yeah, and this checks if it has the same tile ID, which in the 2D case was either land or water. So at this step, the land was disconnected from the water. So I definitely want to do the same thing for the 3D version. Let's look at the scene. So if we have this node right here, then these 4 directions would be my neighbors. And then when I merge everything, it should merge either everything in this direction, make this into one big rectangle, or in this direction, make this into a big rectangle. If we are here, these are on the same height. So actually we have to check where the ramp is pointing down. And for this, the neighbors would be the same, but since there's nothing here, yeah, I think I should always only use the blocks that can actually technically be walked on. So I wouldn't look at the voxel below. So this one would have only 3 neighbors. This one would only have this as a neighbor. And this one would have this and this as a neighbor. And this direction would be a special case, as well as this direction would also be a special case. And then when I change the map, so when I, for instance, delete this block right here, then we have to change the neighbors of all the surrounding blocks and the block below. And then try to do the merging again. Yeah, I think that just makes the most sense. I think that makes the most sense. So, so what I need is a method that says private bool is a valid neighbor. We need this. And we need int 3 voxel position and int 3 neighbor position. And then first we check do we have this? Oh, and we should also do out entity neighbor. Neighbor is default, or rather entity null. Try get value neighbor position out var n, and if we have something here, then we have to check if it's a walkable tile. So we're gonna say return type is not none. Maybe there's a smarter way to set up the enum. We could use flex. Let's. I'm trying not to overcomplicate this. Voxel type helper is walkable. An item to type Tiles, try get value, neighbor position plus private const up new 010. Cannot be const, okay. Plus up. And either we don't have this. Or up type is none. So we need a voxel at that neighboring position. That voxel needs to be of a walkable type. And there has to be either nothing above it, or if there is something above it, it should be none. And yeah, I think that's all the cases. Then neighbor is n item 1, return true, otherwise you return false. And then we say is a valid neighbor tiles position, neighbor position out. Now we can return this to entity. Oh, fucking. Whoops. Huh? What are you doing? Okay, so that works for flat terrain. And for ramps that are pointing down. So with that, these find each other and this finds this, but these do not find each other. So Before we do this, we check one level above. And we say if we have this and up item 2 type voxel type helper is ramp. Then we have to check the rotation. How do we check the rotation? Oh, Jesus. If the block we're looking from is a ramp, then that also changes again. Okay. So this is flat to flat. This is flat to ramp. And then we also need ramp to ramp. And we also need ramp to flat. Ramp to flat. So we get the other direction as well. Okay, so we say if a voxel type helper is ramp, voxel type comp voxel type I could just give the voxel data component voxel data type I didn't even need the position. Okay. There's also the question about the corner pieces, but I'm not gonna worry about that right now. Okay, so we check the neighbor and up. That's where a ramp should be, or a ramp can be. Then we have to get the rotation. It must be facing away. So if we are looking at the, oh wait, also this is not correct. This should be z minus 1 and plus 1. So this is the neighbor in front. And in this case, the rotation should be 0. Um, um, okay, let's say this is not neighbor position, but neighbor offset. And then this is voxel data position plus neighbor offset plus up. And then we know what the rotation should be. So let's make a switch. Up item 2 rotation K0 is 1 is 2 is 3 and default So for rotation 0, let's put this into a method. Private bool is connected ramp, and we need the offset, the neighbor offset, and we need the rotation. So here we would say rotation must be 0. Wait, no. Neighbor offset must be z minus 1. Neighbor offset must be x minus 1. Neighbor offset must be z plus 1. And this is x plus 1. And then we can say and is connected ramp neighbor offset up rotation item to rotation. Okay. So we're checking if there's something there. We're checking if that thing is a ramp. And then we're checking if that ramp is facing the correct direction. That should be everything. And then we say neighbor is up item 1. And then we call this try get neighbor. Okay. The next thing is ramp to flat. This is similar to this, except this is down. Down plus down. And down, this is not a ramp. And then call this is connected flat ramp. Might make another one ramp flat. And here we need our own rotation. So we need a voxel data rotation. If our rotation is 0, that means the flat is facing forward, or rather backward. So Z must be 1. When we're facing this direction, we are like this. So all of this has to be inverted. Two rotations. Yeah, okay, that checks out. Disconnected ramp flat. And then that is a valid neighbor. So I have to return true. And then for ramp, we need oh, there are actually two cases for ramp to ramp. Oh no. Oh wait. This oh man. Oh boy. Shit. Wait. We have oh yeah, the ramp can also point down. There are too many cases. No way. This is the down pointing ramp is also covered by this. I think the way I've set it up just doesn't make any sense. So this is flat to same level. This is flat to the ramp that's pointing down is always on the same level, but then we also have to check the rotation. So oh, and if both are ramp, then the rotation has to be the same, which actually makes things a bit easier. So we check if there's a block and there's nothing above it. And we have to check. Voxel type helper is ramp. N item 2 voxel type either not a ramp or or is connected ramp flat neighbor offset n item 2 rotation and that would be it's the neighbor down. Then this has to point up. So it's rotation 2. Yeah. Flat to same level. Flat to upper ramp. Ramp to lower flat. I have to pee. So we say ramp to lower ramp. Tiles get down. This is a ramp. And down rotation is same as voxel data rotation. Then that's a neighbor. And then we need ramp to upper ramp. Yes, we need this guy here. Let's just put everything there. Up plus up. That's a ramp. And the rotation check is still the same. Okay. That should be all the cases. Okay. Now I would like to visualize this for starters. Let's go back into stress tests. Let's make a copy. We don't need this. We don't need the grid. What we do need is the voxel world. Put this in here. Don't need this. Okay. And then we need to call this guy. And we're gonna do that with another debug script, voxel stress test. Mono behavior. I actually wanna listen to the Spice and Wolf OST. Kevin Penkin just makes incredible music. Stress test. No, that's not the right one. Voxel stress test. So, and here we need a private voxel world. This needs to be the public voxel world. And we need a button that says create graph. Which would take the voxel world data and chuck it into the voxel maps. Wait, no. Voxel graph creator. Graph creator. Graph creator. Create graph of this. This just puts everything into our entity world. Okay, first let's check if this works at all. We start this. Oh yeah, why is it? Something's happening. Ah. Hello? Oh. Stress test? Oh, but the stress test doesn't even... Oh. Yeah, let's remove this. Okay. Then I would like to steal the camera from here. This should be here. Voxel world debug Um, or no, maybe let's just call it fly hammer, fly 3D hammer. That in here. Don't need this. Directional light. Now we should be able to load this. Here we are, and then we create the graph and we get exceptions. Camera controls. Preview object. Okay. So this is specific to the so this belongs in here after all. Web controls. Let's make a copy. That in here. And then we need a copy of this without all the voxel stuff. Don't want this, don't want this. Don't need any of this, I just want the movement. Voxel. Text update. I need this and this. Remove Control. This one. $205. Mm-hmm. Forward. Oh, right. Forward. Ah, don't need this. Hmm. Why is this not working? Huh? This does work. Movement. Oh, speed is 0. Oh. Rotation. Events. Rotate. Camera controls. Rotate this. I need. Okay. So we load this. Chum, 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 chum. And then we create this, and then we get this error. Unknown object type has been deallocated. It's not allowed to access it. Voxel graph creator 25 tiles. This needs an allocator for no temp. No. Initial capacity 256. Should also put a using here. Tiles. Okay, not using. Then I think we need this anyway to persist. So we do this. We call this disposable. And then on dispose, we say tiles dispose. And then here we say using. Well, not really. Actually, we also need this to be persistent. No, actually, no. At least not yet. Because all the entities will be there anyway. Deserialize. Okay. Then we say create graph. And then we check out the entities. And we should have a lot, yes. We shouldn't have as much because we say if the voxel type is none, then we do nothing. And also, if there's something above that's not none, and tiles try get value new, not new, composition plus up out var up either we have nothing on up or up item to voxel child is none. For this, let's just say on start, we also want private voxel world debug. Public deserialize. And then create. No, we have to wait. So let's make a new method. Public async unitask deserialize async. We do this, and then we await this, and in here we say douche and forget. Deserialize async, await, and this has to be async. Oh, and we need to reference unitask. In there. And then we create the graph. I don't have to press the buttons all the time. Okay, then let's go. Bush. Okay, we still have a lot. I think that's more than it should be. It looks too much. Voxel graph creator. If this is none, or we have tiles, we have one above. Wait, or tiles up, and that's none. Yeah. still the same amount. Huh? This is 3 by 3. Every chunk has 16. So this is 16 times 3, so 48 times 48 should be 2000 and then some. If voxel type is none. Let's split this. If voxel type is none, then we continue. And if the upper neighbor does exist and it's not the upper neighbor exists and it's none, then we continue. Yeah, that should be. It should be right. It's not. Okay, let's check. Voxel type is none. We continue. Ah, yeah, no, that's right. We create all the entities here. This is only where we do the neighbors. No, we don't want entities for all of these. That is, I think, not a good idea. So we say we can't really check what no, yeah, we can, of course we can. We have all the data available. So we say voxel dot type equals none, continue. And so that only is the problem when we have to check another chunk. So let's add a new method here. Voxel data get voxel int x int y int z And this is global coordinates. So we get the chunk by int chunk x is x divided by size x that's the chunk, and then we need the int local x is x mod, not the size, but the chunk size. We do need to remember this chunk size. Wait. If this is the chunk size. Yeah, wait, we have to multiply this chunk size. I think, right. If it's 16 and my chunk size is 16, no, then I just divide by chunk size. Then that is 1. It's like 8, then that's 0. If it's 32, then it's 2. Yeah. We divide by the chunk size. And the local is, yeah, mod the chunk size. Mod the chunk size. That would be 8 mod 16 is 8. 16 mod 16 is 0. Yeah. And then we wanna get the chunk data, chunk x, y, z. And then we want to get the voxel, and that is our result. It's a voxel by global coordinate. So now we can say data get a voxel, voxel position plus up. And we also want a version that takes a vector get voxel vector 3 int position return get voxel position x y z. else that can be cast? Vector 3 inch? No. Then I need my conversion helper. Static vector to vector 3 int. This int 3 value return new value x, value y, value z. To vector. Oh. Ah. To vector 3 int. Get voxel. Oh yeah, and this. If this is outside for some reason. Then we. This is struct, right? Yeah. If x is smaller than 0 or y or z are smaller than 0 or x is bigger than size x times chunk size or y is bigger than size y times chunk size or z bigger than size z times chunk size, then we just return a new voxel with position new XYZ rotation 0 and type none. That should be greater or equals. Okay. Get voxel that. Type is not none. The voxel above is not none. Then we continue. And then that should be that. Yeah. We only create the graph for blocks that are out in the open. What? Huh? Oh, yeah, fuck. This. Wait, voxel position. Oh, this is the local position. Local voxel position relative to chunk or voxel position in chunk. Yeah, then this doesn't really make a lot of sense. Just put this to 0. So this would be the global position. And that's the position we need. Position plus up like this. Okay, this is a lot less. So now this should be about right. Still not super sure. Still more than I expected to be. I expected to be 1/3 of this. 48 times 48. Okay. In any case, let's draw this, draw the connections. And we're gonna do this with on draw gizmo selected. And we need, we only really need the entity manager, world default. And we're gonna say entity manager get. No, I think we need to make a query. Entity query builder or just entity query new. Wait, how was this done? Test. Trogismos. Node rect entities. Using entity query node rects new entity query builder. So we do this here. This would be voxel data comp entity manager. This undestroy this dispose. No, whatever. Entity manager. Okay, so that's all our entities. And then we say for each, wait, this is voxel entities, entity manager, get component data, voxel data, this voxel data. And then we need vector 3 position voxel data. Oh wait, this is the global position, right? Yeah, global position. So we should also call this global. Maybe let's just call this world position. World position. Well, it's not really, it's not even really the position. It's really just the position in the array. With global position. Position is global position. Can I cast this like this? Yeah. And then we say position y divided by 2. Because we have half height for our blocks. And then we say, wait, what do we say? Entity manager get buffer node transition buffer entity read only. Transitions. For each transition and transitions. The transition buffer. This gives us another entity. Entity manager get component data voxel data comp of transition node other voxel data vector other position is this and also divided by 2. And then we can say gizmos draw a line there. But we should draw it slightly up. So let's say vector up position plus vector up divided by 2. Let's see if that works. Or if that's gonna blow up my PC. Nothing happens. Voxel entities is nothing. Oh. Yes, of course. Blah. Still nothing. Because we have else. A component with type no transition buffer. It's not been added to the entity. Are we sure about that? Dynamic buffer. No transition buffer. With voxel data component. Get buffer. No transition buffer. Dynamic buffer. Add buffer. We add this to everything. Why would there be one without the thing? Oh, none of these. Wait, there was one. But a lot of these nodes don't have the buffer. How come? How come? Global position. Oh, maybe it's global position? We create a bunch of entities. Huh. Voxel position, chunk position. Hmm. Hmm. Then we go through all of this. Let's say tiles S now contains key global position assert is false. Yeah, that is the problem. But everything has already been created. So why are we even... Oh, no, yeah, no, that's right. First we... create graph First we load everything, then we create the graph. Okay, so that is the problem. Then let's find out where we are colliding. Pixel position. Maybe this is 0 or something. Zero, zero, zero. Hmm. Hmm. Global position 0, 0, 0. Voxel position. Okay, so this is 0. Okay, so this. Oh, this must be plus. Oh, wait. Yeah. This is voxel position plus chunk position times data size. Nice. Chunk size. Chunk size. Public int chunk size. Chunk size. Chunk size. Yeah, this is the local position. Yeah. Oh. Again. Zero, zero. Hmm? So this is the true 0, 0, 0. Chunk size is 0? No, that's not right. Chunk size is 0? What? Huh? Position 0, 0, 1. Chunk size here. World data. Oops. that wait, yeah, because I am deserializing and I only just put this field for chunk size in. So this constructor isn't actually called. So this is 0. Hmm. Worlds. So I'm gonna just try and put this into the JSON. Voxel world data, chunk size. Should be right here. Chunk size 16. The file is too big. Can we do it with Notepad? Mm-hmm. Okay. Still? Um, oh, wait, I haven't marked this as serialize. That might be the problem. Ah, okay, here we go. This only sort of works. Ah, yeah, because the position of the block is at the bottom. So this is just plus up. Yes. Maybe plus 0.75. Oopsie. Yeah. Okay. That looks pretty correct to me. We ignore these for now, the corner pieces. Okay, cool. Yeah, that is what it should look like. Okay, give me 1 second. We should also have the... still have a lot of these. Oh well. So the next step would be to merge these again. And for that, the algorithm should be pretty much the same. Okay. Let's commit first. Voxel world to graph. Okay. Merging. Node merger. So this guy gets the tile aspect. Entities. Merge nodes. Does this even need to change? Tile data. Can extend. don't think there's actually a lot that needs to change here. So let's make a new class, voxel node merger. I'm just gonna copy all of this. And this is gonna use not the spawn data. Voxel data component with all to entity array nodes. I'm putting this into an array apparently. Voxel world data. Data size. Public vector. Total size. Size times chunk size. Total size. X, Y, and Z. Get component voxel data entity position. Get component data. Voxel data. Voxel data. Position X. Y, Z. We don't want the spawn data. Instead, we probably want this. Merge nodes. And this. Nodes. Hmm. And then find neighbors. Why is this? Oh. Okay. So we go into merge nodes. This. Then we want to do. We go through all the possible tiles. total size X, total size Y, and total size Z. Merge tiles. This has to be int 3. Z. Merged entity. Merged node rect. So these are still rects. Merge node is this. Merge tile voxel data component. Voxel data component merge. Let's call it merge node. Oh. Merge node entity merge. Fucking hell. Merge node data. Bottom left should be Z. Okay, yeah, no, there will be some changes here. Can extend push voxel data com merge what did I call it? Data something. Can extend merge node data. Bottom left. Bottom left Y. Nodes. Length. Okay, so this must be Z. Oh, wait. No. This is still Y, but this is 2 now. Because we're still going... We're going in Z direction, but our extents only have 2 dimensions. Bottom left. Bottom left Y. Nodes. We also need the Y now. Int Y. So this is actually Z. Extends. This is Y. Can merge voxel data comp. Voxel data comp. Let's just say these can be merged if the voxel type is the same. Check tile, get component data, voxel data comp. This merge tile contains merge tiles X, Y, Z. This was already merged, then this is false. Yeah. Can extend. Push, push, push. Merged node rect bottom left extends up. So this is not up, this is now forward. Extends Y minus 1. Extends X minus 1. Failed. Forward. This should still be okay. Mark merged. Merge tiles. This also needs a Y. Oops. Int Y. This is Z. X, Y, Z. X, Y, Z. Merge tiles, add this new one containing rect. Is this. Add component data to that thing. Okay, so this should be okay. Add component data, merged entity, merged node rect. Okay, yeah. Walkable, we ignore this completely. Okay, so that should be okay. Then we go to find neighbors. Okay, and in here there will be some changes, I think. Query builder. Oh, this also needs a Y now. This needs a Y. Okay, let's just say, let's just add a Y in here. Y. By default, this is 0, so that shouldn't be a problem for the 2D version. And then when we create this, we say Y is Y. Okay, find neighbors. We get the node rects, all of them, and for all the rects, get the component data, hash set neighbors. We ignore this. Bottom left. So this again is Z. Bottom left, blah, blah, blah. This is rect Y and Z. Containing node rect. Try get containing node rect. This position. Z and 2. Get component data. Of this. And containing node rect is not current rect, and we ignore this. Then we add this as a neighbor. We say rect Y and Z. Rect Y and Z minus 1. Rect Y and Z plus 1. Position. Bottom left. Yeah, so in this, we walk along the edge of the rectangle that we've just drawn. And we check in each direction if there's a different rect. And then we add that as a neighbor. We don't consider elevation changes right now. But that's okay. Let's just see if it works like this. So a voxel node merger. Voxel node merge nodes. Voxel world data. Wait. Create graph. Yeah. And then we want rect entities. Node rect. Node rect. Node rect. Rect entities. Voxel nodes. Rect nodes. Okay. And then in draw gizmos, let's add a bool. Voxel connections. Draw rect connections. If draw voxel connections, we do this. If draw rect connections, we do something else. So we have to go through all the rect entities. Actually, can I just copy this from the other one? Stress test. Rect entities. Yeah, that should be it. Okay, I still need my loop. Rect entities, entity manager, get component, blah. Extend +1, 1. Center, bottom left. Draw wire cube. Center cube. Node rect Y. Center is bottom left plus extends divided by 2. Center X. Node rect. Minus 0.5. Minus 0.5. And this would be plus 1. Size extends. X and Z direction and height 0.1. Okay, let's see. I remember that last time this took a while to get right. Argument exception. Entity manager, voxel node merger 41. The entity does not exist. Nani? Check node. Nodes XYZ. Nodes. Nodes. Okay, yeah, these are not all filled in. So that's right. Nodes. Ba, 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 ba. So what do I do? And merge. If check node is entity null, then we return false. Is that right? Can extend. I think so. Okay, so here we also have to check if this is null, if merge node entity is entity null, then just continue. Notes. This also has to check. Entity is this. Entity if entity is entity null, then return false. Okay. Direct connections. Oh, damn. Yeah, that looks pretty much correct, don't it? Yeah. Oh, this is excellent. So we are obviously missing some merges here. And then we also need to draw in the neighboring things. This looks good. I'm surprised. Genuinely surprised that this pretty much works right away. Okay, so in terms of height, it's a bit weird. Just no direct. I don't add anything. So here we should add 0.5. But why is this? Oh yeah, because I have to divide by 2. This divided by 2 and plus let's say 0.7. No, this. No tracked. It's 1, it's 0.5. 0.5 should be here. And then we add 0.7. It should... What? Oh, wait. Is that because... Yes. We're missing an F. Nothing's happening. Oh. Okay. Now this looks okay. So okay, now let's draw in the connections. Draw rects. Rect. If draw rect connections for each. I think I also can steal this from my other thing. I think this is this. Entity manager. No transition buffer. Oh yeah, I should do this. In here. Don't need this. Get the buffer, set the color. Go through every neighbor. Calculate the center of the neighbor. Bottom left extends. Center. Oh. Yeah, okay, so this has to be minus 0.5. This is this, but with the neighbor and center Y minus 0.5 need for this. Right, central connections. Okay. Okay, so yeah, this is a bit hard to see at times. But looks pretty correct. So this is connected to this one. This one is connected to this large one, which is connected to here and there. This one is connected to here and connected to this. This is also connected here. And okay, so this looks like one line, but it's not. So this is connected here. This is connected there. This is connected to the one in the back. This one is connected there. Yeah. So now we only need to take care of these elevation changes. Yeah. Elevation changes. So also the slopes don't get connected because obviously they're different voxel type. So do we just say they can be merged if they're on the same elevation? Since everything is walkable right now, yeah, let's do that. Voxel node merger says voxel data comp global position y is this. I'll have to rethink this when we add more different voxel types. Okay, so yeah, now this is one. This is one. Oh, this is actually a good question. Do we... Yeah, these shouldn't be merged. Yeah, same here. Yeah. So checking the Y is not enough. I mean, no, I don't want them to walk like this. That's not the point. But if this was like a... triangle, but I don't even have that block right now. And even if I had it, you wouldn't be able to walk up there. Okay. Then we're gonna say this obviously has to be true. But it's not the only thing. So let's say if this is not equal, then we just return false. And then we have to check pretty much the same thing that we had to check for the neighbor nodes. Let's see. We gonna say if voxel type header is ramp a and type voxel type helper is ramp B. If both are a ramp, then they have to have the same rotation. A rotation equals B rotation. If A is a ramp, um, is a ramp is B ramp if is a ramp, neither one is a ramp, I mean, this is always true. Both are not a ramp, then we just return true. If both are a ramp, is A ramp and is B ramp, then we check the rotation. That must be the same. But we can't have both as a ramp because then the elevation can't be the same. Okay, we ignore this case because they can't be at the same elevation. Wait. No, they can. Yes, they can when they're like this. Not like this, but like this. Then yes, they can be at the same elevation. And then they also need the same rotation. Okay. And the last case is that only one of them is a ramp. So voxel data comp ramp is a ramp, and it's A or B. Voxel data comp non-ramp is this. And then we need the relative position. So we say relative pos ramp minus non-ramp. Global position, global position. And then we have to use this same thing here. Let's just make this public static. Return voxel graph creator relative force and ramp rotation. And neighbor offset Z1 rotation 0. This might be the wrong one. Rotation is 0. That means the flat is facing in minus Z. No, I think this is correct. Let's just check. Yeah, okay, this is correct. These are now disconnected. That is okay. This is disconnected. These are connected. These are connected. These are not connected for some reason. So this square right here is disconnected because of this ramp. But then it should go here and find all of these. This is okay. This is okay. Oh yeah, we also have to check these neighbors. So many cases to check. At every step. This is fine because we're ignoring triangle. This looks weird, but it is correct. I mean, technically these could be one. Hmm. Hmm. Okay. Then let's go and do the elevation for the neighboring of rects. My neighbors. Contain node rect. So we just check the direct neighbors, but we'd have to, if we're at the position of a ramp, then we also have to check down. Containing node rect. Position. And we also have to check the facing. Oh, gee. So we have to do something like get component data voxel data comp entity voxel data at this position. Position. Right. No, I can't. I can't anymore. I'm a little bit tired. So I'm gonna stop here and I'm gonna leave myself a note. Connect to RAM. Connect via RAM. I need a break. I'll see y'all next time. Thank you for hanging out. Emote.